Welcome to the next session. That is the third part of this technological system session. So our case speaker is Robert Amor, that you know. So Robert, the floor is yours. Start when you consider.
Okay, thank you. And I hope everyone's enjoyed lots of wine, lots of great Spanish food. You're in a nice warm room, which I think means that everyone's going to fall asleep. So I have to keep you awake. And I'm going to keep you awake by claiming that we need to look more at AI. And I want to talk about why I think AI is important for us to be considering. So I'm going to start off about why AI, and I think a lot of people already know all the claims and the changes that AI is making. Talk about the places where AI is really good and where it's going to change the world, where we can use it now. Look at some of the work that people are already doing around BIM and around regulations, just to give you an idea of the sorts of things that AI is being used for now and where it doesn't go right. And also to talk about humans and why intelligent humans are a really good thing to have. So AI. So Wikipedia will tell us that it's perceiving, synthesizing, and inferring information demonstrated by machines. So intelligence, but artificial, not human intelligence. And I guess a lot of people get excited about it. Computer scientists like me get really excited about it because we're thinking about strong AI, or we're talking about general AI, and this is creating a system which is comparable to a human across a wide range of different abilities. And that's not what I'm going to push here, because I don't think that's useful for us or that's particularly interesting. We don't have to wait for that for us to be able to do something with AI. So what I want to talk about is weak AI. And weak AI is where AI is really good at solving one task, a very particular area where it gains expertise in that area. And it might not sound as great as strong AI, but I think weak AI is going to be very, very useful for us. And I want to talk about those uses that we have. You'll see I'm interested in where AI gets really good. And we'll see a number of examples where AI achieves better than human performance in the tasks that it's been trained on. And again, I think that's a place that we want to be, that we are using AI in these places where it can achieve performance better than humans can, or at least as good as humans can. And that's something we should be taking advantage of. And it's something we can take advantage of now. These systems exist in many places. So I want to talk about 4 things that I think AI is really good at. So one place is where it's skilled, having a skill. So places that we see that is an image recognition. You've seen in the news and in papers, the AI can detect cancers as well as a doctor can. So these places where we can train on many, many images, where we know whether something is of one category or another category, and AI can be at least as good as a human in achieving performance in that area. Another example you might probably remember, is when AI beat the world leader in the game Go. So AlphaGo back in 2016. God, that's almost 10 years ago that an AI system beat the world champion in Go. The people who developed that, they said at the time that they did that competition, they thought that their system was going to beat the world champion perhaps 4 times out of 5 in a game. So the world champion would win 1 game out of 5. It didn't. The world champion didn't win any games, so it was beaten thoroughly. One of the things that I think is really interesting in AI and AI learning is that it doesn't learn like we do. So 6 months after that competition, the AI system would only be beaten once in 1,000 times. 6 months after that, it's superhuman. So a human is never going to win the game of Go against an AI. Okay, and it's that exponential learning which I think is one of the things that we need to understand about AI systems, what they're able to do. So it's not learning like humans, and I think we put human labels on what AI systems are doing, which are perhaps not helpful. It's learning, but it's not human learning. And so the abilities that it's gathering are abilities which grow in a very different way. If I'm learning how to play Go, I get better slowly. It's this incremental thing over time. AI system is exponential and it's learning really fast. One of the other things that we know with the learning, well, is that we don't know. We don't know what the AI has learned. Okay, we're training it, we can see its performance, but it's a black box. We don't know under the hood. We don't know what it is that it's actually found to be able to deliver the performance that it's getting. And again, you've probably seen places where AI has gone really stupid. So I think Google has a system which recognizes cars. And someone discovered that if you turn the car upside down, it thought it was a turtle. Okay, so how was it working out that it was a car? We don't know. And so again, the way that it has learnt and what it's learnt, it's not human. It's learnt something machine-like, and we don't really know what it is that it's learned. One of the projects that I've done on health and safety, we've been looking at PPE, whether people got their hard hats on, and I put my hands over my head, and it thought I had a hard hat. Been trained on thousands of images of hard hats. So what had it learned? So often what we see when it goes wrong in ways that humans would never go wrong. An upside down car is still a car. None of us would make that mistake. And even if the AI is better at identifying cars, it's the mistakes which are non-human, which are the things that we really get upset about and obsess about. One of the other things with AI, I guess, is that it can learn. We can give it more information than we can give a human very quickly. We're terrible. The I/O channel of a human is awful. I'm speaking to you, 52 words a minute. That's terrible bandwidth, isn't it? So I can get some concepts across to you, but a computer system is going to have 1 million pages in the time I say a word. So the amount of information I can impart to you or I can impart to a system is very small. And what it can give back to us and what we can process, again, I read 52 words a minute. That's really slow. How many standards can I read in my lifetime? I don't want to read them all, but, that's my input-output capacity is really low, and AI is not. And so as you'll see, that it's able to process a huge amount of information, and in the learning, able to learn and play itself, process lots of information faster than a human can. So in the game of Go, there's only a certain number of games that can be played. If AI is playing against a human, it takes hours to play a game. It can play itself, and in milliseconds have another game and try another game and try another game and try another game. So the ability of AI to learn is also based on the speed of computers, and the input-output, the amount of information it can process is far more than humans can, which makes it very capable in that learning process. One of the other approaches, the other capabilities that I think AI has, so it's attentive. And again, that's an attribute that humans are terrible with. You put someone in front of a monitor watching a site to see that everyone is wearing their PPE, they get bored after half an hour, keeping that focus, keeping that attention. Humans are just not good at that. Humans are not good at driving, keeping the focus on the road, not on your phone. So that's attention that humans are really, really not good at. AI doesn't care. It will just keep focusing on whatever it's been told to do forever. And so that's really good. So if we're checking plans and we have hundreds of plans of a building and we need to find every room which has more than 20 people and make sure the door is swinging in the right direction so we can leave correctly after a fire, a human is going to be finding it difficult to keep attention and find all of those rooms and do all of those checks. AI doesn't care, and so that attentive nature is an attribute which is really, really important and useful for us. As you know, it's very knowledgeable. You know, it's read the internet, it's read every book that's out there. So the search that we have from AI is covering the body of human knowledge, and so that's far more than we're able to do with my poor input capacity. I can't read all the information on the internet in my lifetime. I can't read all of the standards that exist in New Zealand, let alone across the world. But an AI system is able to read all of that information, hold all of that information, give you answers back about the information that's there. So very knowledgeable. And the final area is high IQ. So again, having processed all of the information on the internet, the top systems now have looked at trillions of data points and the associations between those data points, and far, far more information that you or I are able to process in a lifetime, and those statistical connections that it's made are things that it can apply, as we see with ChatGPT and all of these other tools, to give us quite amazing results. So 4 areas where I think AI is really beneficial, and I think in each of those 4 areas there's some aspects of that will work really well in the area of building permitting. And so the title of my talk, which is AI thinks your building is compliant. So I want to make the argument that if we are applying some of those capabilities of AI systems, which exist now and are getting better at an exponential rate, that we're able to do some very interesting and useful determinations on the consents that we're looking at, the permitting that we're doing in our systems. I was going to talk just very quickly some of the things that we need to do if we're processing consents. So we've had lots of talks that have talked about this. How do we take the documents, the regulations and codes that we have, and turn them into something that a computer can use? We have to pull out all of the text. We have to understand and categorize it all. We have to translate it into something that's able to be computed. And we have our BIM models, and we've seen there are problems with the BIM models that we have, and we have to make those better. The codes and standards, as we know, they're prescriptive, but they're also performance-based. And in a lot of ways, that's not a problem for AI, because it can infer how to access and determine things on both of those types of information. Our codes and standards also have tables and figures in them. Figures are a bit more difficult. I don't think we've really got to understanding what's in figures. Understanding what's in tables, image recognition is getting very good at being able to pull apart tables and understand what's inside tables, as well as processing the text that we have. So I want to talk about some of the things that people are doing, and where AI has found its place in those. So some of the performance-based checks that we might want to do on a building are quite difficult. So this one's looking at toilets, and toilets are not meant to be visible from a public space. And how do you determine that? That's quite a hard thing to work out for a computer. And so here you can see an AI approach, which is trying to determine all of the ways that you could look at a toilet from public spaces, and hence look at that performance-based prescription and say yay or nay, does it meet this particular aspect? We've seen, I talked about BIM not being great, and the models that we're seeing not being great, and wanting to be able to fix those. And again, AI is really good at looking at these patterns and saying, well, this is not a staircase, but it's a whole set of slabs. These slabs are in a particular order, and that kind of looks like a staircase. And so AI can learn, to look at the models that we have and say, well, this is my best guess, this would be a staircase, or this would be some other object that hasn't been labelled properly inside our documents. Tanya talked about graph-based analyses, and again, I think that's a really important way of us looking at the information that we have inside BIM and trying to understand what's there. And so these processes of semantic enrichment that we've been hearing about and talking about give us a way of looking at lots and lots of models and saying, well, what's the usual configuration of a kitchen to a hallway to a bedroom to a toilet? Toilets and kitchens don't usually come next to each other. If you look at enough models, you can work out what the probability is of the use category of a particular room. It doesn't always work, and as we've seen in the other talks that people have been looking at, we can get really high accuracy, 80, 90%, 95% accuracy for many different types of rooms, but we're not going to get 100% accuracy. So we're always going to have cases where the AI system is not going to give us the right answer. It's going to give us the right answer really quickly for many, many categories, but not always. And that's something that we need to be able to work with. And again, from this paper, you can see getting around 80% accuracy in determining different room categories across a wide range of BIM models. So you might say, well, okay, that's not enough, but think about how fast it's doing that versus how fast a human would do that. Okay, so again, as a way of being supportive to humans, you can do 80% of the categorization within milliseconds, and the human has to help with some other parts of it, but you're cutting down the work that is needed for it. So lots of approaches to look at that. We can look at the ratios of areas and volumes to try and work out what sorts of objects there are, and again, AI systems which are trying to do that. But again, not always working. This paper is showing some objects which got categorized as walls. And again, as I say, we don't know how AI has learned. And as humans, we would be aghast, that window is a wall. Not a wall. No human would say that's a wall. Yeah. But again, the AI system is categorizing the vast majority of things correctly. And where it makes mistakes that humans wouldn't make, but it's still doing a very good job of it. Similarly, looking at the models that we have, and I say, well, things should join up, and often our BIM models don't join up, so let's make them join up. And so we know that the beams should be supported; they shouldn't be floating in free air. So let's look at how we can change the model so we are going to get a good outcome for the quality of the model. And again, going back to the graph-based approaches, we can look at egress and finding ways out of the building. And so this example is finding the paths from different parts of the building to an exit. But you might notice that exit 2 is not actually an exit. So again, finding many correct ways of determining what's safe inside a building, but not always perfect. And that's something that we have to look at and worry about. Similarly with the regulations, we've seen today many tools that people are building to do automated code compliance checking. The CoreNet system, I guess, is the one that everyone looks at and says, that's the gold standard. I think a gold standard because Singapore has really got very prescriptive codes, and it's much easier to check than other countries, but still a view of things which are to come. One of the things I'm really interested in use of AI is doing question answering. And so again, this notion of 600 codes that we have available in New Zealand, how do you know what is required for a particular aspect of a building that you're putting together? And question answering, giving you more than just search, being able to provide a query, and it can give you the answer to that query. So here you can see it's the question, given a hearth slab is on a timber floor, what is the minimum shank diameter of a screw which holds the supporting structure? Okay, and it says it's 4.88 millimeters. Okay? So that's not search, that's actually finding the value out of the codes and providing that back as an answer to a person. Okay, and so we could do that for any of the codes in any of our nations and provide a tool where people are able to ascertain, what is needed for a particular situation by asking natural language queries and getting results back. You can see it also points to the clause, but again, it's not going to be perfect. It's not going to find the right answer every time. This tool was about 80% accurate for the first answer. If you looked at the top 5 answers, it was over 90% accurate, but it's still not 100% accurate. But who's able to do that quickly with the codes and standards of their country now? This can tell you answers within milliseconds. We talked about ways of turning codes directly into computable form. And you don't want to read this, but that number, that's about 90% accurate in the translation of a code. There's a New Zealand code about fixing ties that located no less than 320 millimetre centres for stacks up to 600 millimetres wide. And you can see that there's some code there which kind of looks about right for that. Very close to the target of what an expert says that code should be. Doing that's not always fun, and the AI is not always going to give you a good answer. And sometimes the good answer that it's not going to give you is because our codes are terrible. And so in New Zealand, we know there are many, many inconsistencies in the codes. There's a couple that I've put up here. So the second one there, you need a panic bar on a final exit used by more than 100 people. But one of the other codes says that actually you need it on any door, not just the final door. And so that depending on which of the codes your AI is processing, you're going to get different answers. And that's not the AI's fault, that's our fault, that we have codes which are inconsistent and we haven't fixed all of the problems. And I think all jurisdictions will find this if you go across all of your codes in your country, that they're not consistent in what they're saying. And that's difficult for an AI system. I showed you a really good example of being able to turn text into code. Here's a really bad example. So a much more complicated clause from the New Zealand codes, and the system is producing something which is not going to give you a good answer. Judith's done some work. So we talked about AI systems are going to be really good at saying what the answer is based on the code, but that's not what humans do. So if my tread depth is 1 millimetre out, the AI will say, well, that's wrong. You're failing that clause. The human expert's not going to say that's wrong. Yeah, a millimetre doesn't matter. And so how do we teach the AI what tolerances are allowed? And they will change in different countries, probably change for different project types and types of buildings, maybe change for different localities depending on who is doing the checking. So again, we have, as humans, we do things which go against the regulations that we have, and that's really hard for an AI to be able to learn what that is. As you have heard, much of what we need to be able to be successful with AI is lots and lots of examples. And so Google's really good at telling you if it's a cat or not. And why is it good at doing that? Well, everyone's put up pictures of their cat. They say, here's my cat. My cat was playing with the wall. My cat, and there are millions and millions and millions of examples of cats. So yes, really, really good at knowing what a cat is, because we as humans have told it, this is a cat. Not so many of these though, So the difficulty that we have is that there are far fewer models that we have available to learn from. There are not millions of BIM models out there for New Zealand that we can learn to determine whether it's a compliant building or not a compliant building. And as Judith and others have talked about, that we have this real problem of getting enough data to be able to do the learning from. So we need to get more data, and as we get more data, the systems are going to get much, much better. a number of people have said, well, those regulations are really hard and they're inconsistent, and we can't really trust an AI which has been learning across those because of those difficulties and the inconsistencies. Why do we need them? We have all these examples of consented buildings. Why don't we just look at the consented buildings and learn what's consented and what's not consented? And then you could just give it a plan, and I would say, well, I think this will be consented because I've seen lots of buildings like this that have been consented. And then you don't have to process those 600 codes and standards and try and understand them and try and understand, what the depths are between the range hood and the sink and all those things which are there. You can just look at consented plans, and that could be enough to be able to say that it is a valid building, that it is going to be consented. And that may work, and I know people are looking at going to do that, and we're going to see systems which will try that. I think the fun is that not all of the consented buildings that we have are actually approved properly. So there are mistakes in there, and so our AI systems are going to be learning across mistakes in the consented buildings. And we just have to hope that the number of mistakes is much lower than the number of really good decisions that have been made, so we're not learning how to consent really bad buildings all the time. So I guess the thing that I want to stop on is that AI is going to be really good. It's going to be really good at narrow things. It's going to be really good at finding us answers to very particular aspects of the consenting process that we need, the permitting process that we need. It's not going to be perfect. And to me, this argues for the human in the loop, that we don't just trust AI. We don't trust many systems. We shouldn't trust many computer systems. There should always be a human expert who's there looking at that and making the final decision. And I think that is something that we're going to need. We always have high expectations of the systems, the AI systems that we have, and an expectation that they do far better than humans before we're going to trust them. And I think that asks some questions about, well, how are we going to get to that? And if I'm a permitting officer in New Zealand, all I need to have is a technical qualification in engineering, and I can become a consenting officer. What does AI need to have to become a consenting agent? How are we going to test that? And I think that might be something that we need to think about. What is the test that we would give an AI system to say, well, I trust you to make this decision? And I don't know what the question is or what the answer is for that. In New Zealand, also, you have to be assessed every year to see if you're competent or not. And maybe that's part of what we do with the AI. We assess it continuously to see if it's giving us competent answers. Does it give the same answer as a human would when it's looking at the same sort of building? But then the human could be making mistakes. So, yes, I don't know. So I'll leave you with this one. Humans are really good. We can't get rid of them. AI is fantastic, superhuman performance in many things. We should be using it more, but don't trust it.
Thank you, Robert, for this interesting topic and introduction to the artificial intelligence. I guess it's time for questions. I have one very silly question, a very binary question. I went to a conference 1 month ago and someone said, okay, the artificial intelligence is not artificial or intelligence. Do you agree with this question, with that affirmation?
Well, it's definitely artificial. I mean, it's not.
Yes or not?
So I've seen a number of philosophers argue about whether AI is intelligent, and the majority of them say yes, that it meets almost all the tests that a philosopher would have for intelligence. And so, yeah, it's very hard to argue that it's not intelligent.
Okay.
Which is scary.
Okay. Thank you. Questions for Robert? Okay.
You did a really interesting point about not trusting AI, I believe. I've been trying AI for a long now, and you can ask the same question negatively or affirmatively, and you will obtain two different answers. And my question is regarding the BIM models that we saw, and how many BIM models did you use to train the AI, and how many BIM models do you think you will need to have some most reliable results?
Yeah, so you would have seen the work that I presented there wasn't my work, so that was work from lots of researchers in the community, mostly from Israel, who are doing the work on the semantic enrichment. I think the rule of thumb is 1,000, that you need 1,000 examples as a starting point for your training. And yeah, I don't know about your country, but there's no way that we have 1,000 BIM models in New Zealand.
And we have like more. I believe right now we have 500,000 BIM models, not all of them for architecture, but the structures other. So we are really interested in how to exploit the information that is there. So I will be happy to
and
see.
so the question is how good a quality. You know, so you don't want to learn on bad quality, bad data. So you need to
Those are BIM models for projects from our clients, so I guess at least they have the minimum quality to pass the.
Yeah.
I don't know. I'm just curious. Now we have been thinking.
I have lots of BIM models from top architects in New Zealand, which are atrocious.
Yeah.
You know, they look really, really nice, and you would never want to build anything from them. But yeah, you know, so I think, the thing that I think we always forget is that data is fundamental to what we're trying to do, and good quality data is really hard to find, and you need lots of really good quality data to build a good AI.
Hi, thanks for the presentation. Interesting. So I'm trying to connect the dots between the presentation that I saw yesterday and what you said today, and it's about asking the right question to the AI model, right? Yesterday was don't ask if it's 2.5 meters or 2.5, but rather say it's way below those 2.5 meters, right? You think that safety factor is the way to deal with this kind of models when the analysts say or get a message that says this model might be 80% off, you know, to deal with those inconsistencies, because then you will be always in doubt.
Yeah, I think it depends on what the question is that you want to answer, because I think there are some things, you know, so like image recognition, you know, I think you don't need that buffer for that. You know, we can learn to be very, very accurate, superhuman performance in recognizing particular defects in a building, cracks, all those sorts of things, and you don't need a buffer on those. But for other types of questions that you might be asking, then yes, you know, like do this work, you know, looking at, you know, what the range between which answers are going to be acceptable or not. Yeah, those ones you do.
Thank you.
Okay, thank you, Robert. Thank you. Okay, our next presenter is Francisco Javier Diez from Technical Company. You are from Bilbao, I guess, right? So the floor is yours.
Thank you, Gonzalo, for the introduction, and to the organization for inviting me to this magnificent congress and conference. I am Francisco Diez from Techniker. Techniker is in the Basque Country in the north of Spain, but it's not so sunny in Barcelona. Well, I am working to building permit management data space. It's a work of Gonzalo Gil, Ricardo Romero, Ignacio Lázaro, and me. Sorry. Okay, we start with a short overview of the DigiCheck project. After that, we talk about the architecture of the framework of the DigiChecks, the data space architecture that we are developing in the project, and finally some details of the data space functioning. The DigiCheck project is a Horizon Europe project. The title of the project is Digital Environment for Management of Permits and Compliance in Building and Construction. It's a project that started in June of 2022 and will finish on May of 2025. The main objective of the project is to create a framework for the management of permits and compliance checks. It's based on 5 main principles: a standardized permit ontology, a digitization of permit processes, the building permit rules, building on international initiative and standards, and respecting data sovereignty. That is perhaps the difference or the main topic of the presentation. Well, I say that the consortium is led by IFCC. There are other 2 construction companies, Realia and Cree Buildings. They are the pilots of the project. There are 2 research institutions, University of Gent and Techniker, 1 standardization company, Bureau Veritas. The other partners works in digitization and technology. IDP, Ibermática, that now is AIESA, Nianest, Centech, Digital Construction, the Digital Twin Association, and INCOM. Well, this is the architecture of DigiChecks. That the objective of this architecture is to be able to manage all type of permits, not only permits for one institution or one part of the permit. The permit has a life cycle, and in this life cycle there is involved a lot of actors, participants, institutions, and the idea is that this architecture works for all of them. Of course, the processes are defined by PPMN, and there is an orchestration engine, messaging business process, that will execute the process. There are other services that are used, the core services that are used to manage the data space, the catalog of services, the vocabulary provider, and after that there is other services that are used for compose the different process that will be involved in any permit management or in any some of them will be compliance check services. And of course there is a interface with external databases, external services, external tools that is using the gateways. The idea of the data space is to manage the data of all these processes, but respecting the sovereignty of the data, the use control of the data. That the idea is that, as you know, there are a lot of data involved in the permit process, and this is not a central architecture; it's a distributed architecture. The data is in the owner of the data, not in a central repository. This is the architecture. Has 2 main parts: the architecture of the data space. The upper part is based on the Gaia X framework, is the governance framework, and the bottom up is based on the IDCA reference architecture, the data sharing framework. These two initiatives are now currently the most active initiatives in the world of the data space, and until now they are the standard more used. I am not going deeper in the components because it's very technical, and of course I have no time to do it. But I will say that the central part of the main component is the IDS connector. That is the component that share the data, send the data to the provider for the consumer, and control the usage of the data. Is the component that is engaged to enforce the user politics about the use of the data. The functioning has two main parts. The first part is the onboarding to ensure the trustworthy of the transmission of the data, or the sharing of the data. You need certification. You need a connector that is certificated. We are working on developing this connector in DigiCheck project. Every participant could be consumer or provider, or both of them need to be certificated, to be in the data space management, use IDS connector, and the service offering, or the data offering of a service provider must be also certificated. Well, when you are certificated, you can start sharing the data. This is the sharing the data. The consumer, the provider publishes data in a catalog, a semantic catalog of services and data, and the consumer searches for data in this catalog. When the consumer finds the data that they want, they initiate a negotiation on contract with the service provider. But this negotiation usually is not so complex. Usually, I want to access to the data when the data has this politics. Do you accept or not accept, and these kind of things. When the contract negotiation is accepted, the protocol of transfer starts, and in the transferring of the data and the sharing of the data, there is a validation that the structure of the data is correct. No? For that, the connector of the consumer and the connector of the provider checks the validity with the vocabulary provider in forms of SACL patterns. It is all okay. The data is transferred to the connector of the provider, to the connector of the consumer. This is all for my sake. You can ask me any question now in the coffee break, or you have this.
If someone have questions, please, now is the moment, better, for one or two maybe.
Hello, did you create the data space online that people can follow all the requirements that you just made, or is it like a proposal for an architecture to create this framework, or how does that is published?
It's a working on process. We are now developing the data space, and we hope that we will be available for using the pilot in July, August, more or less.
Okay, more questions? No one? Okay, thank you. Okay, our next speaker is Ana Ferreiro. I said correct the name because in the beginning we put the wrong name in the web, so sorry about that. So she is from the SIPE company in Valencia, Spain, so the floor is yours.
Hello. Okay, my name is Anne. I'm an architect and I work at SIPE. Today I'm here actually on behalf of Czech Project, I believe, and more specifically about, or on behalf of our software development team. Maybe I have done this presentation and maybe I'm going to explain the architecture of the platform, but not maybe in such a scientific way, but I hope you understand it. No. Okay, so what is a Czech project and what is a digital building permit for us? For us, a digital building permit is a relationship between mainly these two stakeholders, no? The designer and the municipality. This is a bureaucratic relationship. This is an administrative relationship. This is a really painful relationship sometimes. And this relationship, as all we know, and we have been seeing yesterday and today, is a really complex one. It involves a lot of topics and concepts when we talk about digitalization of the building permit. But I believe there's three main concepts for Czech architecture, which are, first of all, rule checking, then BIM and GIS, and third, the idea of interoperability. Just a little bit for you to know, on top of this architecture, of course, are our partners. We are 5 software companies. We are also 3 universities and 1 technological institute who are also providing digital solutions. So we have there 10 providers of digital solutions. We have also building a smart and open geospatial consortium such as a standardization bodies for BIM and GIS. And of course, we have the 2 most important stakeholders, which are 4 municipalities and the designers, represented in this case by 2 architectural firms and 2 construction companies. Before starting to explaining the architecture, I want to say that the Czech project did an incredible job mapping the process, mapping the architecture, and this job is or will be available. Most of it is available already in the outcome section of our web. So if you want to take a deeper look on what we are doing, for sure you can go there and see more scientific view of the, let's say, work that we are doing. Okay, so let's start. How Czechs fulfills this relationship between the designer and the municipality? First of all, we have a BIM Service Center platform. BIM Service Center provides the framework for the project and provides different modules. In this case, for the designer, BIM Service Center Corporate, where they can develop projects. Also, a BIM Service Center is connected to Czech tools in the project, and the tools are just in between the designer and the municipality, and I think this is a core idea of our architecture, and I believe also a guy yesterday from Brazil talked about the same, which is the idea of pre-checking. So the project will be pre-checked before the submission, and then the municipality will review the project. But what we want to do is to avoid this conversation that sometimes goes for really long, and to try to minimize this conversation. Then for the municipality, we have BIM Service Center Validation Module. That is a module for review. I must say that BIM Service Center Corporate was built before Czech project, and BIM Service Center Validations is being built because it's not finished in the project. Regarding digital checks, which tools is check providing? We have different types of tools, I must say. First of all, we have checking software. Here we have the three tools for urban checking, for rule checking, Verify 3D, VisiMap check, and SciP Urban. And another important concept is that we don't want you to use all the tools that I'm going to show you today. We want you to use the tool that fits better to your requirements as a municipality or a designer. We also want to interoperate to avoid vendor locking, somehow. So we have the checking tools, and these checking tools are connected through an open API, an API REST that we develop in the project. Also, we develop a module which is called Build Server Center Developers, which allows any developer to access the API and also to manage their application and connection with the platform. And somehow this closes the first loop, So you have the designer with the project, then you have the checking tool, and then you have the municipality. But on top of those checking tools, we have other tools, which I believe are crucial for all this process, which are BIM and GIS converters. So we have IFC georeferencing tool, IFC to CTGML, and CTGML to IFC. We also have BIM and GIS data validator, so to validate the formats and to see that everything in this file is correct. And finally, we have the digital signature that I believe that we don't have talked a lot about digital signature in this conference, but I believe that's a crucial point of the whole process. In this case, the Roots is providing that service. Okay. That's for the idea of the architecture. I'm going to show you really briefly the interfaces for some of the tools developed. For sure, I will need a lot of time to show you videos and how they work, but I will happy to, anyone from tech will be happy to answer your questions. Just for a quick remember, BIM Server Center is providing these three modules. And I just want to say that BIM Server Center was made like 10 years ago and currently has 200,000 registered users and more than 500,000 contributions. So we have a lot of data already here. And an important part of the project was not to start from scratch. This is just the interface for BIM Server Center Corporate, and a really important thing of BIM Server to know is that BIM Server is structured in projects. It's a platform that is structured in projects. Projects are made by contributions from the different users or the different people that are working in this project, and contributions for us are a list of files. So that's the general structure of the platform, just to give you some more information. Then we have BIM Server Center validation, so they will also have projects, and they will be able to review the projects in the platform. So the information that has arrived from the checking tools in the platform. Then we have BIM Server Center developers, and here you will be able to access the API, and also is documented in Swagger, and we have some documentation. So it's free to access, so please, if you are a software developer and you want to try it, is there. You can do an account free also for BIM Server Center. It's free of use, so you can do an account and try it. And here the developers will be able to manage the projects. And one really important feature for the building permit process is that developers will be able to link software with validation accounts with municipalities. So somehow I will say, like, my tool, you can use my tool for this municipality. That's the idea. So in this sense, the idea is that more than one tool could be used for the same municipality. It's not, there's just one source of truth, but more than one. So this is an important feature. Then we have the checking software. This is a Verified 3D. It started as a model checker, and now it's being adapted for urban checking. We have here Cyp Urban, that is a tool that we started 7 years ago, and is only urbanist related. Here just some captions, and I must say also that all these tools, of course, are connected to the Open API, so here you can see a project with the contributions and the files for each contribution. Then we have BCMap. So these first two tools, Cyp Urban and Verify3D, are BIM-oriented, so they are based on tools that were BIM-oriented. And now we also have BCMap Check. That is a tool that it was GIS-oriented. So again, this tool is being adapted to do all the urbanist checks, and also is connected to BIM Server Center, so you will be able to access the projects, etc. Then we have a CTGML to IFC georeference converter, sorry. That's one of the tools that we are providing, also connected to the platform. IFC georeferencing tool, and this is available on GitHub. Again, I told you, like, all the outcomes are in our web page, so if you want to access this outcome, it's there, linked. Okay, I'm just finishing. IFC to CTGML, same on GitHub. And then we have also the data validator, CTGML check, IFC check, also on GitHub now. And IFC exporters, which we are using, we are developing an exporter for Revit and one for Archicad, and we are using IDS as a base for the exporters. Finally, we have the IFC digital signature, and these have two, let's say, modules. One is for signature, and one is for the review of the signature. And basically, that's an overview of all of the tools. And thank you very much, and we will happy to answer questions.
Thank you, Anne, for this presentation. So, time for questions. Who have one question? Okay, again.
If nobody asks questions, I keep asking questions. That signature, is that a separate file next to the IFC file of the? Is it something that it's added to the file, like the digital signature?
I believe it's something that is added to the file. I'm not the expert in digital signature. The Roots is the one developing that part, but I'm sure if you want, you can contact him. What we talk is that they are doing a separate file, and they are really focusing on how to after visualize this file that of course is modified, so you don't have original IFC that any modeler can view, but a signed IFC that only some of the modelers will be able to open.
Thank you for talking about signing the IFC models.
Okay, last question. Well, more questions? I'm running fit.
You can sign an IFC directly with the Autofirma in Spain.
Yeah, but then you will not be able to open it anywhere.
Yeah, you can open it. We have the hubs. The signature generator has.
So Pablo, you have to show me that.
Yeah, at any
Sure.
time.
Okay, maybe it's a contest for the coffee time. Okay, I think it's a good conclusion. Okay, thank you, Anne. Okay, our next speaker is Ilkka Matila from the Cloud Permit, one of our sponsors. So he's from Finland. So Ilkka, the floor is yours.
Thank you.
Sorry.
Yes, I'm Ilkka Mattila from Cloud Permit, and this is a combined sponsor talk and my presentation. So I try to separate when I'm in the presentation and when I'm having the commercial talks. So maybe first a few words about Cloud Permit, and as I'm an engineer, I can use, it's natural that I use numbers to describe the company. So we are 12 years old, we are based in Finland, we currently work in 3 different countries. We work in Finland, Canada, and the US. During these 12 years, there has been more than 1 million applications and permits processed through our systems. And we have more than 15 million documents in our database. So even Cloud Permit might sound like a startup, but it's already far from it. Okay, my presentation today is about enabling BIM in building permitting, and especially to talk about the role of the permitting platform. So in EU Accord project, we have an architecture or the framework how we built this automated compliance checking. In the middle, there is the permitting platform, and it has a few components in it. And when we went into the workshops to talk about the architecture, I thought that we had all kind of same understanding what it is, but actually we didn't. So there was already questions that, what is it used for? Is it like a portal what people use? Is it a data repository? Is it the kind of the system that does the integrations? So what's it used for? And who is it used for? And then we are also kind of mixing the terms of permitting service or permitting software and permitting platform. So I think we kind of need to understand what we are talking about when we have this term. And I think I at least want to try to explain it, because I think we are in the middle of it with Cloud Permit. So I don't want to scare you with this picture, but this kind of tries to answer a couple of those questions that I said. First is what it does. Here's some key elements that we built already in the beginning, what we noticed that was always needed in digital processes, digital building permit processes. First, you have to have what we called permit workspace. I saw yesterday some other terms in other software, but it's the kind of thing that collects all the data in one place, and it allows the access to all people who need to access the data, access the functionalities, and it also keeps track of the status of the application and the permit. Then the collaboration piece. This is because we are online, everybody can access. It's the kind of the biggest benefits comes from the collaboration, the instant collaboration and notifications and so on. Reviews management. So what happens in authorities side? You have to be able to kind of be sure that you do the reviews that you do. Today they're done more manually with the PDF review tools, markup tools, and so on. But in the future, this is the part that will be replaced with the automatic checking. Circulation. There is not only the building department who is in the process, other departments as well, agencies. Permit issuance. After the permit issuance, we haven't spoken in this conference, I think, at all about inspections, but because we want to support end-to-end the customer's process, that's why inspections is very critical part for us. And then at the end, retention and archiving. There was yesterday good talks about being able to access the data, see the process 50 years afterwards or 100 years afterwards. So that's what we have solutions for that in Finland as well. So we take care of the permanent archiving. When we come to compliance checking, it's very important to store the data, so meaning the models, store what are the checks that have been made and the results that have been gotten, so that you can repeat it 50 years from this day. About the UI, who uses it for? So it's the common place where everybody works in the internet, so different kind of UIs. And then the integrations is the key part. So if we want to automate, we need to have the data. It needs to be pulled from the data from the master systems, and not such that we ask the designers and the applicants to fill out everything. Then there has to be the horizontal aspect as well. So it's when you have an applicant process or a building project about building, it starts, as we know, from planning. There is also other like public works, excavation, permits, and so forth. So they can go in parallel. So it's good that they use the same data in the same platform. So this is how we kind of see what needs to be in the platform. And then based on these, you have to be very configurable so that you can meet the requirements in different jurisdictions. On the top right corner, there is the BIM enablement. So on top of this platform, when you have everything digital, you can add those components like the checking, the 3D city model view, and other calculations. And for those in EU Accord project environment, we have been building the APIs or specifying the APIs, how you can make it like a plug and play, so everybody can kind of find the best solution for each need. This is more again what it needs to move from from permitting platform to BIM enabled platform. This is the change I want to show. This is first the new process within ACC is that you first have to validate that your data is valid. You need the data from permitting platform, you need the users in the permitting platform, and then you need the checking solutions. And then you can do the checking and also read the information from the IFC to the applications. And this is the change, and I think this has been mentioned already a couple of times today. So there will be a pre-submission base, which is the self-service. And this is what we promise to the users, to the industry, that you can do it whenever you want it. You will get instant feedback. So that will shorten your lead time for getting the permits. And after that, then starts the collaborative part of the process. Okay, my last slide is about kind of forecast. Where are we now? Is this ready? So as I said, there is already 1 million applications only in our services. So the permitting platforms are there. Of course, there will be more in the market, but there are already systems available. The city model reviews, I think that's quite ready to go market because that's not so dependent on the regulations and how do we interpret the regulations. And when that problem is solved, then we have more and more automated checking. What we need is good examples and success from customers. Next year in Finland, there will be the new Building Act. So we assume that we will have tens of thousands of BIM models. And so we'll have a lot of experience from there. But my key point here is that before you go into the automated processes, you have to have the digital permit platform in place. And now I go back and put my commercial hat on, and I'll show you a video. And this is what we've done actually. This is something that Finnish engineers have done and given to American marketing team. So you can see what's the result. This is from Rava 3 Pro project that we did together in collaboration with Future Insight.
Cloud Permit's next generation community development platform. Building information modeling, or BIM, has been a staple in building design for years. But most governments still rely on 2D drawings and less structured permitting information. BIM unlocks valuable building information that provides easy access to location coordinates and 3D geometry data. Users can navigate relevant spaces like rooms, walls, windows, doors, railings, and roofs with great ease, and better understand dimensions, mass, and the necessary materials that are needed for compliant construction. This helps everyone understand and picture the design. BIM transforms building regulations into checkable rules. AI tools ensure compliance, confirm all requested data is in the correct format, and allow designers to check up to 70% of all zoning and building codes with ease. Now, we're going to look at how BIM transforms modern online building permitting software. In projects with extensive property and building data, manual entry is time-consuming and prone to errors. Uploading models with BIM to the permitting software automates data extraction to save applicants and municipalities countless hours. The software performs instant validation of values and selections, which significantly streamlines the process. The software's capabilities extend to complex calculations, as demonstrated by this building with 50 apartments with automatic equipment information and unit numbers. AI-powered community development platforms streamline decision-making and integrate smoothly with various data systems. BIM and AI are emerging and rapidly growing technologies, and Cloud Permit is ready. Our software is the only one in the world already meeting the new pathways that BIM and AI can bring governments, designers, and citizens together. Designers receive immediate feedback, which expedites the submission process. The software generates pre-submission checking reports for the reviewers. Checking information before submission streamlines the workload for authorities and accelerates permit issuance for applicants. This marks an incredible leap into the future of the next generation of permitting. Get ready for a groundbreaking era in building permitting automation. Cloud Permit, the next generation of permitting and licensing software.
Thank you.
I'm sorry, but we don't have time for questions, so thank you. So our next speaker is Lisa Lenz from Big Company. So, floor's yours.
So hey, from my side, my name is Lisa. I'm the co-founder of Building Information Cloud, which is founded out of the Technical University of Dortmund within my research project. And we are a research transfer project funded by the German government. So to derive startup ideas out of the research programs or like master theses and so on. And we are focusing also on the compliance check of building or construction documents during the whole life cycle, I would mention, from early planning stages as well as for maybe the transfer into the operational phase of a building to maybe just to check if client standards of the documents are met. And today I'm talking about surely the building permit process and our approaches therefore. So our concept where we have applications in terms of the building permit application is one, the building application form tool, which is a guided completion form that we, for example, have in German at least 16 federal states and more different forms for building applications, and therefore we have developed some guidance that is making it easier. And then afterwards, then we have that automatic document checking, where we're checking the completeness. So a lot of speeches were about data quality, and at least somewhere, everywhere is something missing. So one of our approaches is that automatic checking of the completeness of the documents, as well as for normal projects, as well as for BIM projects as well, like IFC models. And at least the legal compliance, so the compliance with the standards and guidelines or legal requirements of the different states. Here I have one example for the technical implementation. So as I already said, we're doing it for IFC models as well as image analysis and text analysis. We're using their neural networks and also keyword recognition, and for example also microservices like lemmatizers to identify different word types as the same in a different variant. The applications and the workflow that I have, building permit tool, so it's also a kind of approach for a pre-checking phase. Then the HII check is the completeness check, as I said, hybrid approach, and we are based on the German regulations for architects and engineers, fee regulations. A BIM tool where we can check the LOI standard, like what you decided in the BEP for your project, as well as the data quality of your BIM model. Quality check, as I mentioned, and I add on that we developed recently, is the chatbig function where you can ask questions regarding your construction project documents directly on the platform. So that's it from my side. Thank you for listening, and here are my contact details.
Thank you, Lisa. Okay, our next speaker is Max Van Riel from Strack Company. So, floor is yours.
Hola, good afternoon. My name is Max, and we're going to do a few things different today. First, we're going to hopefully look at the slides. But the slides are not so that important. I actually wanted to turn them upside down a little bit, because the problem is usually quite clear, right? The issue is that we've been taking an AI-first approach to this problem, and that's kind of new to this situation. I learned a lot today and yesterday about the machine readability of the building regulations. That is something that we are not doing. We are applying AI and large language models to actually rely on interpreting the building regulations, so not in a machine-readable format. The problem is quite clear, but we are also, just like Lisa, looking a little bit before. So we have learned from architects and developers that they want to, already in earlier phases like sketch designs and preliminary designs, know if things are compliant and what is wrong, instead of waiting till a definitive design where a lot of consultants are involved and it takes a lot of time and money at that point to basically change drawings, etc. Many decisions are made about building projects already early on in the phase, and that's what you want to have it checked, and that's where you want to apply AI. So what we've been doing is basically create an AI assistant platform. And what we want to do in the end is to do these building checks, both zoning and design checks that we've been talking about. We're currently in the midst of constructing them, and then I'm telling you, it's not easy. It's something that takes time. But before we started doing that, I said, what can we show to architects that is already a very practical application of AI? And we came to a regulations library. Nothing fancy, it's called a RAG, Retrieval Augmented Generation. It's good for at the kitchen table tomorrow morning, saying that you learned something extra about AI, so not just ChatGPT. So we are ingesting documents one by one about the Dutch building code, the UK building code, and you can ask questions and answers about this regulation. The good thing is you immediately get a source code, so you'll always have up-to-date information, but you can also ask an English question to a Dutch building regulation. So for example, in Amsterdam, there's a lot of foreign architects. Normally a Dutch person has to come to check the regulation. Now with AI, you can just ask the question in your own language and get the answer back. Okay? I'm not really an expert, but Nikhil, my CTO, is. So if you ever want to ask him something, feel free to reach out to me. And maybe we can, pues cambiamos pantallazo. Let's try it. We could fail. So this is actually the platform right now. So this is live. We click on it. What are the light and luminosity requirements of a building? And now the system is going to look up in the Dutch building regulations this actual answer. Yeah. So this works right now for Dutch documents, UK documents, both on a municipality as on a national level. You always see that it takes some time, but luckily it works. Y bajas un poco. So here you see it generating, and you see the source being mentioned. Now you can click down on the source, and you'll actually see it also includes BREEAM standards, etc. So whatever you include. And click on the source, press C, and you see immediately where it is being mentioned. So what I'm going to ask of you, try this tool Let me know which documents you want to have added from which country, which regulation. Let's see if it works. And try to help us, and we'll get you a trip to Amsterdam.
Thank you, Max. Thank you, Max. If I'm not wrong, our next speaker is from Australia. I don't know if she's on the screen. Hello, Nico. Are you there?
Hi.
Hi.
Yes, I'm here. Can you hear my voice?
Yes, we can hear you. You can start when you want.
Okay. Okay, thank you. Good day, everyone. In the architecture, engineering, and also the construction sector, particularly our work with automated compliance checking systems using visual programming languages. My colleagues and I from the University of Melbourne and also University of Central Florida have developed a pioneering solution.
Nico, sorry
to
interrupt you. You have a presentation to show us.
Yes, I share it with you. Okay, let me share it.
If not, it will be difficult.
Okay, let me just. Okay, can you see my
Not yet.
screen?
Now. Yeah, go ahead.
Okay, so cool. That's great. Okay. As I mentioned, my coworker, my colleagues and I from the University of Melbourne and the University of Central Florida have developing a pioneering solution to streamline compliance through innovative technology. As we all recognize, managing building code and regulations in increasingly complex and dynamic, this complexity challenge the industry, often leading to compliance errors and high cost to rework or response leveraging to capabilities of visual programming languages integrated into ACC systems, especially through the Dynamo Revit platform. Our main innovation is a Dynamo-based Revit plugin that employs visual programming that allow non-specialists to efficiently manage the compliance process. These tools combines big data analytics and artificial intelligence to enhance decision making, ensuring compliance with Australian building codes, particularly focusing on energy regulations. This approach not only enhances efficiency but also the accuracy and adaptability of compliance check. The plugin simplified the creation of compliance algorithms and improve real-time visualization and interpretation of complex 3D models. It supports the industry foundation classes standards, allowing seamless integration with BIM models from various platforms. Moreover, it enables custom script integration for up-to-date compliance with evolving regulation. Or empirical case study in Victoria confirmed the robustness of our tool in navigating compliance challenges. Looking ahead, we aim to expand the plugins capability to anticipate and adapt to future regulatory change automatically, for example, by using the mechanism like adaptation. In conclusion, this work not only represents a significant step toward a fully automated and precious compliance system, but also highlights the role of innovation and also innovative technology in shaping the future of construction. We believe this technology will not only benefit the Australian market, but has the potential for global adaptability and adaptation in regulation and transforming compliance into streamlined and also error-free process. And thank you for your listening.
Okay, thank you, Nico. So,
You're welcome.
Thank you. We're from our last speaker. I don't know if here, Daniel dos Santos from Brazil. The floor is yours when you want.
Hello. Hello, everyone. My name is Daniel. I'm with the Military Institute of Engineering, Rio de Janeiro, Brazil. And I will talk about a method for 3D indoor spaces modeling with the parsimony of description. And in the task of building information modeling, we face the problem of creating a geospatial corpus based on pattern recognition which is part of the natural language programming. And our method is divided in three main parts. The first part, we have developed a deep learning strategy to simplify and aggregate, and also to to segment some objects into the indoor space, such as chairs, windows, and others. And then second, we have used a Ransack algorithm to detect some planar surfaces. And the last but not the least part, all the planar surfaces are aggregated to be represented in level of detail. And we validate the effectiveness of our methods over the complex buildings. And as we can see, the simplification part and also the segmentation algorithm can do that without initial values, parameters. And the point cloud that is obtained with LiDAR sensors can be represented with parsimony of descriptions. I mean, we can preserve the structures without loss of information. And in conclusion, the contribution of our proposed method is twofold. The first is that the simplification and aggregation tasks can be done without the initial values, because we are using the deep learning technique in this case. And also the second is that the presentation is done with parsimony of description. And I think that is important to say that our proposition was based on pulses and perception, that an object can be comprehended as assembled from a set of volumetric primitives. So we conceived the indoor environment as a set of planar surfaces, and so it's possible for future storage, manipulations, and visualizations of the data using this kind of method. That's it. Thank you for your attention.
Okay, this was our last presenter, so thank you very much for your presentations, comments, discussions. So we have we have a coffee break right now, and it's important to be here at 4 o'clock. So don't be late, because if not, Eduard will be alone, and we don't like this. Okay? Okay. See you. Thank you.